Hello and welcome to Excel Mathematics TV. This presentation will be about the greatest common factor. In this lesson, we will study how to find the greatest common factor in several ways. Let's start this lesson by learning about a diagram. Have you ever heard of a Venn diagram before? A Venn diagram is a diagram representation that uses circles to show how the elements from different sets are related. It can be used to show common factors of two or more numbers. Thus, we can use this diagram in finding the greatest common factor. Look at this diagram. This is an example of a Venn diagram showing the factors of 24 and 20. Now, let's get to the main lesson, the GCF, or the greatest common factor. Look at the Venn diagram again. This intersection represents the factors common to 24 and 20, right? This means that the common factors of 24 and 20 are 1 and 4. All we need to do now is pick whichever is greatest among the common factors. 4 is obviously greater than 1. Then the GCF is 4. The Venn diagram is one way of finding the GCF. Let's talk about another way of finding it. We can also find the GCF by listing the factors. To learn, let's find the GCF of 12 and 30 by listing the factors. The listing method is pretty easy. As its name suggests, we will start by listing the factors of 12 and 30. The factors of 12 are 1, 2, 3, 4, 6, and 12, while the factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. Now that we have all the factors listed, it's time to find the common factors. We'll just put the common factors in yellow. They are 1, 2, 3, and 6. Which is the greatest? It's 6. Thus, the GCF of 12 and 30 is 6. Let's have a better visualization of the common factors. This is the Venn diagram showing the common factors of 12 and 30. Aside from the Venn diagram and listing factors, we can also find the GCF by using prime factors. Prime numbers are numbers with only two factors, 1 and itself. To learn how to take advantage of the concept of prime numbers, let's have an example. Let's find the GCF of 45 and 105 by using prime factors. We will start by writing the prime factorization of 45 and 105. When we say prime factorization, we are breaking down the number as a product of prime numbers. 45's prime factorization is 3 times 3 times 5, while 105 is equal to 3 times 5 times 7. If you noticed, the factors are all prime numbers. Now that we have the prime factors, we'll proceed to finding the common prime factors. The prime factors are the yellow numbers. As you can see, the common prime factors are 3 and 5. In this method, we don't need to find the greatest among the prime factors. To find the greatest common factor, we just need to multiply the common factors. Thus, the GCF of 45 and 105 is 3 times 5, or 15. What if we want to find the GCF of numbers with variables? Let's talk about finding the GCF of algebraic expressions. 8m squared and 20m cubed are both algebraic expressions. Let's find their GCF. To do that, we will first factor each expression. We know how to factor constants, but what about the variables? To factor variables, we just need to know their exponents. For example, if the exponent of m is 2, then the variable can be expressed as the product of m and m. 8m squared can be factored to 2 times 2 times 2 times m, while 20m cubed can be factored to 2 times 2 times 5 times m times m times m. As usual, we need to find the common factors. The common factors are 2, 2, m, and m. Just like in prime factorization, we just need to multiply the common factors to find the GCF. Thus, the GCF is 2 times 2 times n times m, or 4m squared. For the last one, let's solve a worded problem using a GCF. Let's read and analyze the problem. Abby wants to make bouquets out of 8 anemones, 24 calla lilies, and 40 tulips. How many arrangements can she make with these flowers so that there are no flowers left? To find the number of arrangements, we just need to find the GCF of the number of each flower. Let's find the GCF of 8, 24, and 40. The method we will use is by using prime factors, so we need to find the prime factorization of each number. 8 is equal to 2 times 2 times 2. 24 is equal to 2 times 2 times 2 times 3. And the prime factorization of 40 is 2 times 2 times 2 times 5. The common factors are 2, 2, and another 2. Then the GCF is 2 times 2 times 2, or 8. Thus, there are 8 arrangements possible. That's all for this lesson about the greatest common factor. You can use whichever method you like. Just make sure that you get the correct answer. Thank you, and we'll see you next time.